Hi everyone, my name is Pavitra V, Department of Chemistry. Today we are going to discuss a topic called nanotechnology. Actually nowadays in every field we have the applications of this nanotechnology and it is a burning topic in research field also. So first we will discuss what is the definition of nanotechnology. Nanotechnology deals with the nanomaterials. Nanometer is nothing but it is a unit of length in the metric system or in a measurement system equal to 1 billionth of a meter. That is 10 power minus 9 is the measurement of nanomaterials. So what is technology then? Technology is the making usage of knowledge of tools, machines and techniques in order to solve problems or perform specific function. So in nanotechnology, we are dealing a nanomaterials whose size in nanometers and we are taking the usage of that nanomaterials. That is called nanotechnology. So we will see the definition. Nanotechnology is the study of manipulating matter on an atomic scale. So atomic scale is nothing but having a nano measurement. Nanotechnology refers to the constructing and engineering of the functional systems at very micro level, or we can say it in an atomic level. Nanometer is 1 billionth of a meter, roughly the width of 3 or 4 atoms. So it gives 3 or 4 atoms. When we arrange one by one, the length is nothing but nanometer. Or in other words, we can also refer to the human hair is about 25,000 nanometers width or a wide. So this is the measurement of nanoscale. Next we will move to the applications of nanotechnology. These are the fields in which we are using nanotechnology, like energy storage, in our storage batteries, and diffuse and security for military forces, metallurgy and materials for the extraction of metals, electronics in the preparation of some memory cards, chips like that, storage material, optical engineering and communication, biomedical and drug delivery. Nowadays we have a huge application of nanotechnology in the medical field. Next one is the agriculture and food, cosmetics and paints, biotechnology and in some textile industries. These are the many other regions are there we are using nanotechnology. Next we will move to the some of the advantages and disadvantages of nanotechnology. Every technology have its own merits and demerits. When we come to the advantages of nanotechnology, it is promoting renewable energies. It enables new ways to obtain the stored energy. It is also makes solar panels cheaper and more efficient. So we are using a solar cells in solar panels in which solar energy is converted into a heat energy or the chemical energy, or we can heat up our water heaters using a solar panels, and also solar energy can be converted into electrical energy and we can light the bulbs. Then next advantage is it extends the limits of electronics. Unlike silicon microchips, nanochips will make it possible to build very precise circuits at an atomic level, so that the size of the device will be reduced with a high application uses. It allows a more effective medicines. So already I have told you, in a medical field we have a huge application of this nanotechnology, like arteries can be unblocked, cells can be selectively attacked. For example, in the treatment of cancer, so cancer cells can be targeted and they can easily attacked and cured. Damaged genes can be repaired and faster and more precise surgeries can be performed. These are the some of the advantages of nanotechnology. When we come to the disadvantages, it threats the environment because it is impure or it causes pollution for the nature. This type of technology could cause negative effects on the environment by generating new toxins and pollutants. Next one, it has an impact on job market. So this is a wide problem we are facing due to this nanotechnology: unemployment. The absolute materials and changes in production process could destroy jobs, but this technology could create others. So the men who are doing 100 men's job can be replaced by one memory card or using one application. So this is the unemployment problem nowadays facing people. So it compromises the safety. The properties of this technology could facilitate espionage, that is a spy nature, the production of nano weapons and smart bullets. So in the early days, we will be having a spies who will give information for a military, but nowadays there is no work for that. So we will be having a nano weapons or a smart bullets and a smart cameras in order to observe our enemy forces. So these are some of the advantages and disadvantages of nanotechnology. Then we will move to the another slide. This is explains in the various fields we are using this nanotechnology, same as the previous one. And we will discuss what is nanomaterial then. Nanomaterials are commonly defined as materials with an average grain size less than 100 nanometers. Okay, this is the limit of size of a nanomaterial, which should be less than 100 nanometers. Nanomaterials have extremely small size, which having at least one dimension 100 nanometer. 1 billion nanometers equals 1 meter. So this is the measurement on a scale. Next is the properties of nanomaterials. First we will discuss the physical properties and then the chemical properties. Physical properties: size, shape, specific surface area, aspect ratio. So some of are rigid in nature, and based on their size and shape, we will be having different applications from that. Agglomeration or aggregation state. So that what does it mean? Means you can aggregate or you can join the nanomaterials. So you will get an aggregate applications. Size distribution: the size is distributed equally. Surface morphology or topography: it is nothing but study of the surface phenomena, whether you will be having a surface rough or nice surface. Structure including crystallinity and defect structures. So in crystal structure we will be having some defects. So due to that defect, it will be having a different applications. Next one is the solubility. So solubility, it is more soluble in water because it is hydrophilic in nature. So when we come to the chemical properties, structural formula, and it is having a molecular formula. Composition of nanomaterial including degree of purity, known as purity or additives. By adding some of the impurities to a nanomaterial, you will get a different application. For example, in the case of semiconductors, you will use a doping method, that is adding impurity to enhance the electrical conductance. Next one is the phase identity. We have three phases: solid phase, liquid phase and gaseous phase. So for the phase identity, we will use this nanomaterial. Surface chemistry: composition, charge, tension, reactive sites, physical structure. Photocatalytic properties: photocatalytic is nothing but some of nanomaterials will act as a catalyst, which increases the rate of reaction in the presence of light. Photo means light or the sunlight. And next one is zeta potential. Next, the last point is hydrophilicity or lipophilicity. It is philic means loving, it is water loving, so hence it leads to the solubility, easy solubility in water. These are some of the properties of nanomaterials.